Okay, so we don't need the whole words. We're going to start memorizing that tomorrow. We can't do this on today because we have a shortened class period time. I'm sorry. So, do you remember what I started drawing first yesterday? Let there be a function defined on an open interval. No. I want to see if you can help me here. What point do I put here? A. Is it necessarily defined at A? No, so I could have an open circle. Then we say that the limit as x approaches A of f of x is equal to L. If for every epsilon, what does that mean? What does the epsilon mean? Very good. So I've got an epsilon value there. So what's the mark here? This is L plus epsilon, and I got a mark here. This is L minus epsilon. If for every epsilon greater than 0, there exists a delta. So this distance right here is delta. And so we have A minus delta, and we have A plus delta. And so that's what we have. And now the rest of the definition is what we have to have, but that's what we want to keep in mind. So what we want to do is we want to squeeze this epsilon to become smaller, and it's going to draw this delta in so we can say the limit is exactly at that spot. No funky business happens. We know what the limit is L. And we're going to show you how to do that. Are you ready? The coolest thing you've ever seen in your life. Prove the following statements using the precise definition of a limit. Yeah, I'm going to take my advisory camping this summer. Because I'm the best advisor teacher ever. Oh, if we get through this, I'll show you guys the intro to the next Hobbit movie. It was released yesterday. I can't remember. I was assuming Christmas. Here's what we have to state. This is the portion that you really got to keep in your mind. Anytime you're asked to do a proof, you got to use the definition that you're given. And the definition is that the function minus, do you remember? Minus the limit. So that's the distance between the function and the limit. That's your tolerance. Has to be less than what? Epsilon, whenever the absolute value of x minus a, so the distance between your x value and your a value is less than delta. What we memorized yesterday is what you have to have on the test. That will be one question. And you will get it. Trust me, they got it last year. Okay, so, no, Larry, we cannot switch the A. The A is what it is. So what I do is this, okay? I first fill in the pieces right here. What is f of x? 3x plus 7 minus, what's the limit? 13 is less than epsilon. Whenever the absolute value of x minus 2 is less than delta. There's 2 steps to the proof. The first one is the easier step. Let's see if you can understand. When I gave you guys a level of tolerance, if I said your tolerance level is 0.1, what did you then try to find? yesterday. You try to find your delta. You found your x value, you subtract it from the a value to get delta. So given an epsilon, you need to find a delta. That's our current situation. We need to choose appropriate delta. How do we do that? Make left look like right. It's actually really cool to see how this happens because you generally don't see it right away. The first time I saw it, I was like, well, I did not see that. So profound. Okay, so given an epsilon value, we choose delta. So look at what happens here. You have 3x plus 7 minus 13 less than epsilon. I want to make it look like that. Watch what I do. What is 3x plus 7 minus 13? 3x minus 6 is less than epsilon. You see it now? Ooh. Look at this. Factor out of 3. Can you factor a 3 out of an absolute value and be okay? Yes, because it has positive value. So we factor out a 3, and we're left with x minus 2 is less than epsilon. Does that look like what you have on the right? Pretty close. What do I have to get rid of? The 3. Divide both sides by. So x minus 2 is less than epsilon over 3. Now, so remember what we did is I said if I give you an epsilon, I want you to choose an appropriate delta. So let's say I chose epsilon was 6. What would delta be? 2. See, x minus 2 is less than epsilon over 3. X minus 2 is less than delta. So our delta value that we choose is equal to epsilon over 3. Yep, that's when I said it. I saw it, and I'm like, I'm done. If the rest of math is as cool as that, then I'm totally into it. Yeah, I'll show you now. I'll show you. Okay, all right. So I'm gonna just do a little bit of legwork here. Okay, you don't have to do this, but this is important. Okay, so let me just do one more thing. If delta is equal to epsilon over 3, then can I also write this? 3 delta is equal to epsilon? Question. Okay, what's your question again? We're still working on the answer. We're still on part 1 where you got to choose the appropriate value. Okay? What's that? Epsilon is the level of tolerance. So, like, are you trying to get within 0.1 or 0.01 or 0.001? That's what we want. Epsilon would be 1 over infinity, so we choose delta to be 1 over 3 times infinity. Because there's different levels of infinity. Okay. All right. Shh. Shh. One more piece I have to put here, guys, okay? Watch this, okay? Are you all okay with this? This is the last step I have to make, and this is just... So we made our choice, but I just want to show you something interesting here, okay? You have this x minus 2 is less than delta, right? We know that. Okay? Just because this is going to help us later on when I do the next step. You don't have to do this every time, but you're not going to understand this next step unless I just show you this one little piece. If I multiply this delta by 3, what do I have to do to this? So all I did is I just created 2 more statements that we know are true. We know delta is equal to epsilon over 3. That's our choice. I've also said that 3 delta is equal to epsilon. That's obvious, right? And then I took x minus 2 is less than delta. I multiplied both sides by 3. We're going to use a very basic substitution technique here in just a second. I'm going to run out of room, but it's just kind of a one-liner, but I want to write big enough so you guys can see. So the second step, and then I'll do on the other part. Second step is this. Show the absolute value of f of x minus L is less than epsilon given epsilon equals delta over 3. No. If I had a 2x, it would be delta over 2. If we had 4x, it would be delta over 4. Now, it is true that we could come up with much more complex equations. We are just going to do linear ones. Okay, so I'm not going to take it any further than that. Okay, so now we need to show this. Okay, so you can put your writing right there. I need just a little bit more space. So again, what I said is show, I'll just write so we all see it, show f of x minus the limit is less than epsilon for epsilon equal to delta over 3. Okay, so I'm going to write this. F of x minus L less than epsilon, which is, our function is what? Plus 7. Yeah. Oh. I wonder if I made a mistake in my notes. No. No, I didn't make a mistake in my notes. I just wrote it down incorrectly. For delta equal to epsilon over 3. You're absolutely right. I'm sorry. You're absolutely right. Good catch. That's very important. I'm sorry. So my function minus the limit. What's the limit? Whoop, 13. Okay. Now, would you guys all agree that this is, what I want to show is that the function minus the limit is less than epsilon. That's what I want to show. I really want to do that. Okay? So, right now, I have the function minus the limit. I'm not going to put this less than sign in yet. I've only done the blue part. Everybody see, I just have the blue part, right? Isn't this expression equivalent to this? You okay with that? Still not going to use the less than sign. Does everybody agree that that's equal to this? Now I'm going to use the less than sign. Now I'm going to use this one right here. Why? Because look, I have 3 times x minus 2. Look at what we wrote above. We wrote that 3 times x minus 2 is less than what? 3 delta. So I can write 3 times x minus 2 is less than 3 delta. What is delta equal to? So I have 3 times epsilon over 3, which is equal to epsilon. We'll do it again. Watch. All right, we'll show you. We'll show you. Okay? Watch the steps. I'll outline it in blue. The blue is just that expression written in equivalent, right? The function minus the limit. And then I break it down to 3x minus 6. I factor out the 3. That's all that. Do you see that? And then the green part is that less than 3 delta piece. We stole that from what we had worked with before, right? We've stated that that's true. We know that that's true. And then I took the delta and I substituted in this red piece. I substituted in epsilon over 3. 3 times epsilon over 3 just gives me epsilon. So see what I've said? I've said the function minus the limit is less than epsilon. Question. You kind of do this backwards in order to make the correct choice. That is correct. You've kind of, yes, exactly. A lot of people get here, they're like, didn't we already do that? We've done the legwork, but we haven't formally stated it. See that a lot of times the trick that people miss here is that we're trying to make that statement, and it's where you really include that less than symbol. So we have that function minus the limit, we have the less than, we have the epsilon. Now, as we do a second one, it will start to come to a little bit more, but notice how amazing this is. Let's suppose, again, we've said, let's say that epsilon, this is just a guessing game. Let's say that you want epsilon to be 1 over, 1 over infinity. You want to make it extremely small. We say, hey, I got an x value that can meet that tolerance of error. 1 over 3 infinity. It says you give me any error for tolerance, I'm just going to take 1/3 of it, and I will get you the delta value that will get you there. And so we've completed it. There's not a tolerance of error small enough that we cannot meet. We can meet every single one. Let's try it again, see if we can do one more. One more. That was it. Those 2 steps, that's it. You don't have to write this. This is the formal statement. This is the proof. The first part is the legwork, trying to come up with the appropriate delta value. The second part is the actual statement of the proof. Yep. So let's try again. You're doing excellent. You're hanging right in there. You're doing wonderful. So we want to prove that the limit is x goes to 4 of 3 minus 2x is equal to -5. Do you guys agree that if you plug in 4, you get -5? If we want to prove it, we use the definition. And the definition states the absolute value of f of x minus L whenever x minus a is less than. See, you already know more of it than you thought, don't you? So, let's plug it in. What is f of x? 3 minus 2x minus -5. That has to be less than epsilon. Whenever x minus 4 is less than delta. So I want to make the left look like because right now what I need to do is I need to choose an appropriate value for delta. That's my work right now. Choose an appropriate value for delta. Okay? So 3 minus 2x plus 5 is going to give me 8 minus 2x, right? What can I factor out of that? I want to get an x minus 4. Factor out -2. And that will give me x minus 4. If I factor out a negative out of a absolute value sign, it becomes positive. Yep. Well, because in an absolute value, it doesn't matter. You could break two absolute values that are a multiplication up into two parts. It would become positive. So we've got this x minus 4 is less than epsilon. What do you do to both sides? Divide by 2. And so we get delta, we should choose to be equal to epsilon over 2. I'm now going to make a couple statements that I'll use in the future. Can somebody name one statement that I'll use in the future? 2 delta is equal to epsilon. That's something that will be important. Very good. And 2 times the absolute value of x minus 4 is going to be less than 2 delta. So the last one, I just look at this, and I see if I have a 2 delta, then I'll multiply everything through by 2 to give me another statement that I can use. So the first statement came from right here. We got that, right? Second statement came from right here. Third statement comes from multiplying through by 2. And so I'm going to use those. So that's really kind of the legwork. We chose the appropriate value. So now is the actual proof. That's the second step. We need to show that f of x minus what? L is less than epsilon when epsilon is equal to what? I did it again. I'm sorry, guys. When delta is equal to epsilon over 2. I'm sorry. Mix up my epsilons and deltas. There we go. Okay. So now we show it all forth. What do I write for this first part? We just did it. 3x. Whoop, I'm doing the other problem. 3 minus 2x plus 5. Eight minus 2x. You know, just use your work that you've done above. We're going to use all that work that we've done above, which is equal to what? Haven't taken out the negative 2 yet. When I take it out, it becomes? Very good. Now I have this, don't I? So I make it less than 2 delta. So now I was able to use my less than sign. And 2 delta is the same as 2 times epsilon over 2, which is the same thing as epsilon. We've done it. We just make that substitution. Just make that basic substitution. I just want you to try 2 problems just like we did. And then I'll scroll up and answer questions. I'm sorry we ran out of time. And 17. Page 101, 15 and 17. Just want you to try those 2 problems. Follow the notes exactly. You should be able to get through it. That's the process. Yep. See how I got the 2 times the x minus 4? And you see how that's less than 2 delta? We've said that delta is epsilon over 2. So we substitute epsilon over 2 in for delta. And 2 times epsilon over 2, the 2's will go away and get epsilon. You did very well today. Very proud of you.